Hello and welcome to day 10 of Advent of Code. Day 10 for me, not for you, because it is the 16th and I'm catching up. So let's jump right into it. Adapter array. This is a particularly fun day. I really enjoyed this day. Some kind of cool things that we can do here. So first off, we've got an output of integers that looks something like this. And with the adapters, we have 19 plus 3, 22 joules is the highest rated adapter, and it always starts with 0. So you start off with an adapter of 0, and then you go through all of your inputs and find, okay, what's the difference of 1, what's the difference of 3s. So in this example, we have 7 differences of 1 jolt and 5 differences of 3 jolts. And the goal with our input, this is our sample input, there are 22 differences of 1 jolt and 10 differences of 3 jolts. And you multiply those values together, and the result is going to be 22 times 10, which is 210. 220, because I can math. 220. So let's jump in. Yeah, let's input our sample data, okay, and then we'll keep it very simple for this particular one. We're going to say that there are ones. This is going to be 1, and our 3s. That's also going to be 1. We essentially know that we're going to have at least 1, 1, and 1, 3, because our first one is going to be a 0, and then our first value is going to be 1. Do we know that our first value is going to be 1? Well, in this example, the first value is 1. And then we're going to have a value of 3 there. So we're at the very end. So whatever our maximum value in the data is going to be, that is going to be a 3. So actually the first thing that we're going to do here is we're actually just going to sort the data, right? That will start us off with data that's in order, and then we can just iterate through the data itself. So for x in range 1 to length data, if data x, and I'm actually going to change this. Instead of x, I'm going to from now on use index. It's easier to read. So if data at this particular index minus data at the index minus 1, right, our current index minus 1, the previous index, if that equals 1, then we're going to say 1s plus equals 1. Else if otherwise, if it equals 3, then we're going to 3s, right? And we're going to add that. That is basically it. We should not get any other differences. It should all be 1s and 3s. So if we do something wrong, we're just going to raise a value error, and we're just going to print out that, which will be the value of that difference, and we'll find out what we did wrong. And then all we need to really do is return the 1s times the 3s. Now, there are lots of ways that you can shorten this. You could even end up with like a dictionary where you have 1s and 3s, and then you just add to that dictionary. Oh wait, it should be 3s plus equals 1. Or you could use like a collections thing and things like that. But I think this is relatively straightforward. It's easy and simple to understand. It's not terribly compact, but it's at least easy to read, I think. I think. That's my personal opinion. Okay. Unsupported operand type string and string. Of course, because we have only read the data in as a string, so we need to say data is going to be list map int data. There we go. Okay, 220. Was that right? Yes, 220 was correct. 22 times 10 is the correct answer. Okay, let's get the puzzle input. Prepare for the brightness. Yes, of course, it's always bright. Must be blinding. Okay, so we have 95-ish, 94 numbers here. Okay, and let's try this. 1876. So we will put in 1876. That is the right answer. Yes. Okay, so we will continue to part 2. Relatively straightforward, though, I think. Right? Okay. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Every arrangement needs to connect the different charging outlet to your device. The previous rules about when adapters can successfully connect still apply. So you can have a difference of 1, 2, or 3 between the different adapters. So you go from, oh, this is the 0th adapter to the 1th adapter to the 4th adapter, etc., all the way up. We're always going to start with 0. And we're always going to end with 3 higher than the final number. So there are always going to be, so neither of those are actually going to make a difference, right? Neither of those will actually make a difference. The 0th and the 22nd one, those will not contribute to the difference. So let's think about this, right? So we've got 1, 4. It always goes from 1 to 4 because we don't have a 2 or a 3. But then we get to 5, 6, and 7, right? And it could jump straight from 4 to 7, like it does down here, or it could jump 4 to 5, or it could jump 4 to 6, right? And then 7, and then 10 always comes after 7. So we need to include, oh wait, hang on here. Because we got 5, right? And 5 can jump to 7, and 7 can jump to 10. So we actually know that we can keep track of the branching values at those particular integers. Like we could count how many times that particular integer is used based off of the times the previous 3 integers are used, right? So, for example, this one always comes after 0. So this is one branch. 4, if you look at the previous 3 values, right? If you look at the previous 3 values, 4 and 3 and 2 and 1, right? 1 is used 1 time. If you look at 5, right, and you go to the previous 3 values, you have 4, which is used 1 time. And then if you go to 6, right, and you look at the previous 3 values, 6 has 5 is used 1 time, 4 is used 1 time, and so 6 ends up with a value of 2, I think. And then 7 looks at the previous 3 values. 6 was used twice, 5 was used once, and 4 was used, wait, 5 was used twice. 5. Yeah, no. So 5 was used once, because it came after 4. And then 6 was used, no, 5, yeah. And then 6 was used, and 7 can also come back from 5. 6 can come after 4. Okay, so I think we just need to sum the previous 3 values into an array that represents that location. Okay, let's test this. That's the first example. This is the second example. Let's continue to use the second example here. Actually, let's go back, right? And this is going to be part 2. So we know part 2 is going to have a series of points here that are going to start with 1, right? Because 0 is always is always the first value, and then we're going to have more arrays that are just going to be zeros for now, times the maximum, right? The maximum. Actually, we need to sort the data again. So data.sort, right? And then we can just say that it will be the data negative first value, right? Okay, so we've got now an array print points. Okay, so let me just okay, so now we have an array where we have one branch, then we have 0 branches. Well, we're not there yet, but then we have one element for every single value in the array, including the final value, which is going to be 3, our max value plus 3, right? So we actually have a value for all of these. I think this is correct, okay? So next, we're going to say for r in data, let's just say val in data, actually. It's better than val. Num, for num in data. Naming things is hard. For num in data, we're going to say that our points for that given number is going to be equal to the points for the number minus 1 plus the points for the number minus 2 plus the points for the number minus 3. So it's going to sum the previous 3 values at that particular for that particular record. Now, the interesting thing is that it's going to skip past anything that any values, right, any integers that aren't present in the data. And so we have a 1. So let's go back to our example here. So we have a 1 and we have a 2. Oh, here we go. So we have a 1, we have a 2, and we have a 3, and we have a 4. But then we skip over 5 and 6. Those 2 will remain to be 0. And so when we go back to 7, 7 will essentially be the same value as 4. In that particular branching, in terms of the values, that particular branch will have the same value as 4 did, because 4 only goes to 7. Okay, and then, I mean, what this essentially means is that we just return the final value in the array. So that was 220, and now we have 19,208. Let's look here. 19,208. 19,208 distinct arrangements. You glance back down at your bag and try to remember why you brought so many adapters. There must be more than 1 trillion valid ways to arrange them. Okay, so our number is going to be higher than 1 trillion. What's the total number of distinct ways you can arrange the adapters to connect the charging outlet? Now, what's great about this is that more than 1 trillion here, right? More than 1 trillion means that we might not be able to do recursion, right? It might, maybe that would work, but it would probably take a really long time. But in this case, we're actually only going to be going through the data once, and this will be a relatively short process. So let's bring back our input data. It's this data that's very long. Is this the right data? It looks like it. Okay. Nope. Value error 2. Let's go back. I'm not sure. Maybe that's a previous. Yeah. That can't be right. That can't be right. That must be a previous day's input. There we go. See? Relatively straightforward. So it's more than 1 trillion. So there's this one. So that's millions. Here, this is billions. and it is 14.17, assuming that I'm counting my integers correctly, it is 14 trillion different combinations and change, okay? So let's input this and let's see if we get the correct answer. That is the correct answer. Okay, there we go. That's, I mean, a really simple solution to the problem by just summing together the three different branches, or the number of branches from the three previous data points. Really straightforward. So there you go. Hope this was helpful. Hope this was interesting. I certainly thought it was interesting in terms of a solution problem. So hope this was good. If you have any questions, though, comments, accusations, throw those down below in the comments section of the video. Don't forget to like, subscribe, and share the video if you feel inclined. Anything else, let me know. I want to be here to help, right? I hope these are useful videos, or at least fun videos. So with that, good luck on Advent of Code, and I'll see you in the next video. On to day 11.